interesting science channel.
Dear pals, observing the stars in the night sky is an extremely fascinating activity for scientists and astronomy enthusiasts. Every time you look up at the sky, you can see thousands of stars.
Within each star, there are countless mysteries that you cannot perceive with the naked eye.
So today, Interesting Science invites you to explore the secrets of the brightest stars in the night sky. Enjoy watching the video. Don't forget to subscribe to the Odyssey channel and turn on notifications.
Now, let's begin our exploration.
The apparent magnitude of a celestial body is a measure of its apparent brightness.
Calculated as the logarithm of the photon flux emitted per unit time, it is usually denoted as m. The smaller the apparent magnitude of an object, the greater its observed brightness.
For example, our Sun is the brightest celestial body in the sky, with an apparent magnitude of -26.73. As for the full moon, it has an apparent magnitude of -12.6. These are considered the two brightest celestial bodies in the sky when observed from Earth.
The same applies to distant stars. The brighter a star appears to us, the smaller its apparent magnitude. And now, let's explore the mysteries of the brightest stars in the night sky. First, Sirius. Sirius, also known as the dog star, meaning the sky wolf, is one of the most famous stars in the sky. With an apparent magnitude of -1.46, it is the brightest star in the night sky.
Observed from Earth, the star is located behind the big nebula. To the naked eye, it looks like a single star, but in reality, it is a binary star system.
Consisting of a main star with spectral type A0 and a white dwarf with spectral type DA2. The main star, named Sirius A, has a radius only about 1.71 times that of the Sun, but its surface temperature is quite hot, around 9,940 Kelvin. Therefore, the star's luminosity is about 25.4 times that of the Sun. In the universe, this star's brightness is not exceptionally large compared to the Sun, but because it is very close to Earth, it becomes the brightest star in the night sky. According to calculations, the Sirius star system is about 8.6 light-years from Earth, making it one of the closest star systems to Earth. Its companion is a white dwarf named Sirius B, with a radius only 0.84% that of the Sun, so its brightness is very low, equivalent to only 5.6% of the Sun's brightness. Therefore, when observed in the sky, we mainly see light from the main star, while the companion star is very faint.
Through orbital analysis, the white dwarf Sirius B is about 20 astronomical units, from the main star, nearly equal to the distance from Uranus to the Sun.
At this distance, the star has an orbital period of about 50.1 Earth years. This means Sirius B takes 50.1 years to complete one orbit around the main star Sirius A. In 1977, when scientists launched the Voyager 2 spacecraft to explore the four gas giants of the solar system, they hoped that in about 296,000 years, it would reach a position about 4.3 light-years from the Sirius star system. At that time, it might capture the most realistic images of the Sirius system. Let's wait and see. Perhaps in the distant future, Voyager 2 will approach the Sirius system as planned. Second, Canopus. The star Canopus, also known as Alpha Carina, is the brightest star in the southern constellation Carina, the Keel constellation.
With an apparent magnitude of -0.74, it is the second brightest star in the night sky.
Canopus is a single giant star with a radius about 71 times that of the Sun.
As for surface temperature, it is only about 7,400 Kelvin, but due to its large size, the star's luminosity is about 10,700 times that of the Sun.
Therefore, even though it is about 310 light-years from Earth, it remains the second brightest star in the night sky.
Through spectral analysis, scientists believe Canopus may have a spectral type of A9 or H0.
Hence, the basic color of this star when observed with the naked eye is white. With a mass about 8 times that of the Sun, Canopus may be undergoing helium fusion in its core. It is currently in the blue loop phase of its evolution. It may have passed through the red supergiant stage, but perhaps its size is insufficient to produce a supernova. Therefore, scientists predict that Canopus will become a white dwarf in the future. According to scientists, in the past, Canopus was the brightest star in the night sky. Then, about 90,000 years ago, Sirius moved close enough to Earth. And since then, Sirius's brightness has surpassed that of Canopus. Alpha Centauri is a very famous star in the sky. It is commonly known as the closest star to Earth.
According to calculations, it is only about 4.37 light years.
Because of its very close distance, it is also ranked third in brightness in the sky.
Observed with the naked eye, it appears as a single star. But in reality, this is a star system consisting of 3 stars.
The main star is named Alpha Centauri A, belonging to the G2V spectral type, similar to the Sun.
The secondary star is named Alpha Centauri B, belonging to the K spectral type. It is only slightly smaller than the Sun.
Additionally, there are 4 red dwarf stars of spectral type M called Proxima Centauri.
In this triple star system, the 2 main stars Alpha Centauri AB orbit each other at distances ranging from 11.2 to 35.6 astronomical units. They have an orbital period of about 79.91 years.
Compared to the Sun, Alpha Centauri A is slightly larger in size and mass.
Its radius is approximately 1.22 times that of the Sun.
Its surface temperature is equivalent to that of the Sun. Therefore, its luminosity is only 1.5 times that of the Sun. As for Alpha Centauri B, all its parameters are smaller than the Sun's.
Its radius is only about 86% of the Sun's radius. Its surface temperature is about 500 Kelvin degrees lower than the Sun's.
Thus, its luminosity is only 50% that of the Sun. Proxima Centauri is a red dwarf, so its size and luminosity are very weak. When observing, scientists see it orbiting the binary system Alpha Centauri AB.
At a distance of 13,000 astronomical units, approximately 0.21 light year.
Therefore, it takes about 547,000 years to complete one orbital cycle. In 2016, scientists discovered the planet Proxima Centauri b orbiting the red dwarf Proxima Centauri. By 2020, they discovered another planet named Proxima Centauri c. Both of these planets have mass and size larger than Earth's.
Hygiene Channel has a video explaining these 2 planets quite clearly.
Discovery of super-Earth Proxima c very close to the Sun. Arcturus is the 4th brightest star in the sky and the brightest star in the Boötes constellation.
With an apparent magnitude of -0.05, you can easily observe it in the night sky.
This is a red giant star of spectral type K. With this spectral type, its surface temperature is quite cool, around 4,286 Kelvin. But this is a giant star with a radius approximately 25.4 times that of the Sun. Therefore, its luminosity is about 170 times that of the Sun. Although not extremely bright, because it is only 36.7 light years from the Sun, it becomes the 4th brightest star in the night sky. According to scientists, this star has left the main sequence and is swelling into a red giant.
Despite its large size, its mass is estimated to be only about 1.08 times that of the Sun.
From long-term observation, scientists suspected it might have a companion. But so far, no celestial objects have been detected around it. This suggests that Arcturus is likely a solitary star in the universe. Vega. Vega, or the weaving maid star, is the brightest star in the Lyra constellation.
With an apparent magnitude of -0.02, it is the fifth brightest star in the night sky.
If you often observe the sky, you can easily recognize it at the top of the summer triangle. This is a famous imaginary triangle formed by three stars: Deneb, Vega, and Altair.
Belonging to cycle type 0, the weaving maid star has a quite hot surface temperature. According to calculations, the temperature is about 9,600 degrees Celsius, and its luminosity is approximately 40 times that of the Sun.
Additionally, it is a fairly large star, with a radius about 2.36 times that of the Sun. But because it is about 25 light-years from Earth, it only ranks 5th in brightness. Observations with a telescope in 2006 showed that the weaving maid star rotates very rapidly, to the extent that its poles are thousands of degrees hotter than its equator.
The star takes only 12.5 hours to complete one rotation around its axis.
The weaving maid star is also the subject of many firsts in astronomy.
Specifically, in 1850, it was the first star to be photographed.
In 1872, it was the first star to have its spectrum recorded, and it was also debated as the first star to have its angular parallax measured in 1837. Finally, it is the first star to have a car model named after it, which is the 1971 Chevrolet Vega.
Capella is the brightest star in the Orion constellation and the sixth brightest star in the night sky, with an apparent magnitude of 0.08.
This star is very prominent in the northern hemisphere's winter.
To the naked eye, it appears as a single star, but in reality, it is a star system with 4 different stars, including 2 binary pairs.
The main pair consists of 2 large yellow stars, both with masses about 2.5 times that of the Sun, but both stars have quite large radii. One star has a radius about 12 times that of the Sun, while the other is about 8 times the Sun's radius.
Therefore, the brightness of this star system mainly comes from the main binary pair. As for the other 2 stars, they are quite small and faint. This binary pair is about 10,000 astronomical units away from it.
Both stars are red dwarfs, with sizes and masses approximately 53% that of the Sun.
According to calculations, the Capella star system is about 42.9 light-years from Earth.
Thus, although this star system is very bright, when observed from Earth, it only ranks as the 6th brightest in the sky. 7. Rigel. Located quite far away, about 860 light-years from Earth, we come to the supergiant blue star Rigel. The star's mass is estimated to be about 21 times that of the Sun. S radius, it is about 80 times the Sun. Therefore, although it is very far from Earth, it appears very bright in the sky.
Records show its apparent magnitude varies from 0.05 to 0.18, making it a variable star.
In reality, Rigel's brightness is about 1,200,000 times that of the Sun.
Thus, when observed from Earth, it is the 7th brightest star in the sky. To the naked eye, it appears as a single star, but in reality, there are 3 other small stars around it.
They are named Rigel Ba, Rigel B flat, and Rigel C.
Among them, Rigel Ba and Rigel E flat form a binary star system, located about 2,200 astronomical units from the main star. Therefore, it takes about 18,000 years to complete one orbital revolution.
As for Rigel C, scientists believe it may be an orange dwarf star, with an estimated mass about 3.84 times that of the Sun.
It has a very slow orbital period around Rigel. According to scientists' estimates, Rigel C takes about 250,000 years to complete one orbital cycle around the main star.
As for Rigel, it is a supergiant blue star that is depleting hydrogen fuel in its core. By analyzing the properties around Rigel, scientists have found that the star has gone through a red supergiant phase, then increased in temperature to become a blue giant star. In the future, it will become a supernova that shines brightly in the sky, given its current size and mass.
After the supernova explosion, Rigel will become a neutron star.
Interestingly, if Rigel undergoes a supernova explosion, we on Earth would have the chance to witness a light show. At a distance of 860 light-years,
If the explosion occurs, the light from the explosion might be about 300 times brighter than Venus is observed in the sky.
that is, it would be about a quarter as bright as the moon in the sky. At that time, we could see 2 moons in the sky simultaneously at night.
But scientists have not been able to calculate when the star will explode.
But you know, at a distance of 860 light-years, even if the star exploded right now, we would have to wait 860 years to see the light. This means we have no chance to observe this light show in our lifetime.
Procyon is the brightest star in the Canis Minor constellation, with an apparent magnitude of 0.34. It is the 8th brightest star in the night sky.
Observed in the sky, it appears as a single star, but in reality, it is a binary system consisting of 2 stars named Procyon A and Procyon B.
The main star is a white star with a spectral type F5. With this spectral type, it has a surface temperature slightly higher than our Sun.
But in size, it has a radius about twice that of the Sun, so the star's brightness is 6.9 times that of the Sun. Accompanying the main star is a white dwarf, with a radius only 1.2% that of the Sun.
It orbits the main star at an average distance of 15 astronomical units, so the companion star takes 40.8 years to complete one orbital cycle.
Since the companion is a white dwarf, the light we mainly observe from the Procyon star system is from the main star. Although this star system is not very large or bright, because it is only 11.46 light-years from Earth, it becomes the 8th brightest star in the night sky. 9th, the star Arcturus.
Arcturus is the brightest star in the Pleiades constellation, with an apparent magnitude ranging from 0.4 to 0.46. It is the 9th brightest star in the sky. Observed in the sky, it appears as a single star, but in reality, it is a binary system.
The main star is a blue star with a spectral type B. With this spectral type, it has a very hot surface temperature, up to 15,000 Kelvin. Additionally, it is quite a large star, with a radius about 7.3 times that of the Sun. Therefore, the star's brightness is about 3,150 times that of the Sun. But because this binary system is 139 light-years from Earth, when observed from Earth, it only ranks as the 9th brightest in the sky. Accompanying the main star is a smaller star of spectral type A, orbiting the main star at a distance of 12 astronomical units. At this distance,
It takes approximately 14 to 15 years to complete one orbital revolution.
what's interesting about the main star Achernar is its unusually fast rotation, making it the most flattened star ever known. Estimates, the star.
Due to this distorted shape, there is a significant temperature difference. At the poles, the temperature can reach up to 20,000 Kelvin, while at the equator it's only about 10,000 Kelvin.
So today, Talk 2V and you have together explored the mystery of the brightest star in the night sky. Wishing you an enjoyable viewing experience. If you liked it, please like, share, and leave comments below the video to share with everyone. And now,
Please continue to choose videos on the left or right side of the screen to join Talk 2V in decoding other mysteries of the universe.
looking forward to seeing you in the next videos. Goodbye.
Please subscribe to the Guia Nigo channel to hear this AS.